Yeah.
Do you have the?
Oh yeah, everything is good. Just put the HDMI and you're all set. Oh, I need a HDMI though.
Does this work? Should work. Yeah, it's there. Yeah.
Let's start from.
Okay, so let's start. So the.
Everything is coming. So basically,
Don't do that because everybody's seeing everything. No. Show the first one and forget about it. Okay. Go ahead. Can you make it full screen? No. As it was is better. No, leave it as it is and no. Stop. No, Ranky, no. That way, no, because it's no. This one. Okay, so welcome to the to this meeting. For those of you that this is a little bit saturated. Sorry for the problems we are having with the video. My co-chair has a new laptop, and my laptop has some problems in talking with the Beamer apparently. So for this is NFVRG, is our first official meeting, and the no, doesn't work. So move it. So just to start, this is the IETF IPR policy for those of you that should be aware of this, and take note that this is how we apply, how our IPR policy is applied to whatever you say or show in this meeting. This is very much connected with the usual IETF network, that is a little bit different because this is a research group. Just a few remarks of where you can find almost all slides. You know that we have two slots. One is this one, the second one here as well after the SDMRG. And we have almost all slides that Colonel one set. One is still waiting for, are available in the URL. So if you know of anyone that is could be interested in participate remotely, you can tell them about this video. And well, just a reminder for those of you that are not enjoying the participation in the NFVRG mailing list, it is available on the on that URL as well. Well, as usual, we are looking for note takers and people willing to be scribed on the Java room. Sarah Banks volunteered before we started, but still I have not seen her, right?
She should be coming in.
So, well, she's coming. So she's extremely appreciated for that. But yeah, a second note taker would be really. So if any of you are willing to take that, you will earn a star like this that you can put on your laptop. And this is something that you could show or your laptop or your badge, and you can show off around any social event in town and when you go back home. Any volunteer? Well, at least, well, thank you. No. So, you want one? Well, we can talk about that later on. And anyone willing to connect to the Java room and bring some, make some notes there and take any input from the outside?
problem is that I don't have a Java client with me, so. Okay, let's move on. So just something that thinking about presenting the agenda with we were discussing is precisely about the interest that we could have precisely to make and to use the NFVRG, among other things, as a focal point for announcements that could be of interest for those of us that are, well, working on research activities in NFV. This is a list of the events that are related to research in NFV that we are aware of, not necessarily, this is not a calendar or whatever, it's that we think could be of special interest. You have here the list. I won't go through one by one, just talking about them. You have there the list, you have there the URLs. Use it, and if you know about anything else that you think could be discussed in our next meeting in Prague, just let us know. And the final one, which is about the agenda. As you know, we will have 2 sessions. First one starts now and will end about 3. And it will be focused mostly in the documents that have been already contributed, and updates to the documents that have been already contributed, with the idea of making evolve the results of this research group. And the second session, well, after that first session, the SDNRG will have a meeting in this room. So I hope that many of you will stay. And after the SDNRG, we will start a second session of the NFVRG that will be focused more on reports on current activities and recent results. And if you are, for example, coming from the presentation during the lunch on open source, and if you want to hear about how open source is being applied in NFV, there are a couple of.
So, Daniel King. So the SDNRG isn't meeting in here after the break. They're meeting in the international room. Ah,
really?
So don't stay here.
Oh, sorry. I was sure it was here. That's good. Thank you then. So don't stay here if you want to go to the SDNRG. If you want to wait for the coming of the second session of NFVRG, you could stay here.
It's something called Roundtable, but that's legacy.
Ah, yes. Who cares? Yes. And the second session would be there will be a couple of presentations related to open source projects. One related to a particular deployment, and then a study on how an assessment on how you should use your hardware, how you should select your hardware for NFV. So let's start. We have a very packed agenda. First presentation is from Katalin Mirosu. So yes, I have been told, Katalin, since this is being transmitted by a video conference, and for all your speakers, that you'd better stay in that rectangle while presenting.
Oh, okay.
So don't move around, because otherwise.
Otherwise disappear from the.
Yeah, you disappear from the image, and it's not nice. So.
And I should try to eat the mic as well.
Exactly. Well, no, take it if you feel more comfortable. Take it.
So that's okay. Right. Yeah. Thank you.
Go for it.
So I will talk about the draft that we have discussing DevOps for software-defined telecom infrastructure. Next slide, please. Although this was the 0.1 iteration of the draft was not presented before. So this is the first time with a full presentation for the draft. As an introduction, we noticed that there is a significant work on network virtualization technologies and their management, both in academia and in a lot of industry fora, including IETF and IRTF, NHC and the TM forum. So the purpose of this document is to have a discussion opener in the NFVRG and describe a set of principles that we consider relevant for applying DevOps ideas to managing software-defined telecom networks, and then identify challenges related to developing tools, interfaces, and protocols that would support these principles and leverage standard APIs in order to simplify operations tasks. Next slide, please. DevOps is many things to many people, and I can bet that a lot of people in this room have their own definition of what DevOps actually means. We identified two roles for developers. One which is a service, we call it a service developer, and this is a person that assembles a service based on virtual network functions. And the other person is a VNF developer. This person is somebody that actually writes the code for a virtual network function. And of course, there is a role for the ops side. So there is also an operator in the picture. We identify these 4 principles taken from an IBM book. Deploy with repeatable, reliable processes. For us, this principle is very much about being able to use identical processes in the development and testing and operations environment, that these processes are actually trusted by both the operators and the developers to be used in a production system, and that visibility is provided into the workings and stages of these processes. Then develop and test against production-like systems. This means that we will need isolation properties in the system so that we can set a slice aside and then experiment with a newly deployed service. And we have to acknowledge that there will be frequent customizations of all the services and all the VNFs that are being deployed on such infrastructure, and we have to be able to handle these type of customizations. Then monitor and validate operational quality. This means that we will need to have established procedures for validating the quality of the service. For very specific services like Ethernet services, those procedures exist. For other services, especially if we want to have our own well-defined service based on, I don't know, 10 or 15 or 20 VNFs that we just decided to assemble together in a service, such procedures don't exist. And amplifying feedback loops between developers and operators. This is mainly related to cultural and corporate procedures, so I don't think we can address them in this standard. Next slide, please. Right. In terms of challenge areas, we identified 2, 4, 6 challenge areas that we described in the standard. I am sure that today we are not going to have time to look in detail into each of these areas, and I would kindly ask everybody to read the standard, the draft, and then give us some feedback on the details. But the areas are stability for software-defined infrastructures versus continuous changes. This is something that it's a major disconnect between the developers and the operators. The developers are the persons that want to put the changes as fast as they can into the infrastructure. The operators are the ones that really like to have a system that operates in a very stable way. Then we have another challenging area given consistency, availability, and partitioning trade-offs for the VNFs and for the infrastructure that supports the virtual network functions. In observability, we have a lot of very interesting issues related to the scalability, the distribution of the monitoring infrastructure, automation, verification, what to do in terms of verification of the infrastructure, so what to verify, what to check, and scalability, because especially when we start talking about verifying stateful network functions that are part of a network function forwarding graph, this becomes really complex, and there is an explosion in terms of the amount of checks that could be done. Troubleshooting, we'd like to have automated workflows, and then very interesting identification and definition of performance metrics for the DevOps processes. Next slide, please. When it comes to stability, an adaptive routing system, it's stable most of the times, and the individual protocols were defined to reduce the instability intervals. But we always have some cases of instability, and that's given because of failures of configuration errors or protocol design. So it's very challenging in a software-defined infrastructure to have control loops that would work correctly in the presence of failures, in the given the variable delays for communicating with a distributed set of devices, and to account for different changes in network conditions, especially when these control loops are nested. Next slide, please. When it comes to consistency, availability, and partitioning, a very interesting question is what combination is most appropriate for a software-defined infrastructure, and for which kind of scenarios. Are there scenarios where we can choose just consistency and availability, or is it availability and partitioning better in other scenarios, or shall we choose consistency and partitioning? And the advent of software-defined infrastructure actually changes the way these trade-offs have been done. One example here, with a standard routing like OSPF, if I have availability, it implies consistency, because the control plane partition usually implies a data plane partition. If the 3 OSPF hellos are missed, then what happens is the originator of those messages decides that either the connectivity is gone or the other the other software agent is gone. But in any case, what happens is that that link is not going to be used and everything is rerouted. Now, with SDN, this changes, especially with OpenFlow, because even if the SDN OpenFlow control plane is cut, then the switch itself would continue to forward without any problem, waiting for the control plane to be restored. Next slide, please. When it comes to observability, there are lots of trade-offs between the overhead of the monitoring, between the intensity in which we want to monitor, number of monitoring instances that we'd like to have deployed in the network, distributed operation and information exchanges between monitoring functions. This is very interesting from a research perspective. The configurability and conditional observability, in particular for self-adaptive algorithms. This means that we would have all kinds of self-adapting algorithms trying to estimate the network state and then feed this information onto control loops. And when it comes to automation, we would like to have an automated mapping of monitoring functionality from a logical forwarding graph to virtual and physical instances executing in the infrastructure, and also automated replacing of monitoring when orchestration or the controllers decide to move the location for compute or network resources. Next slide, please. Okay. When it comes to verification, can we expect that the orchestration and controller to export or log every change that happens? And then the middle box verification is a huge challenge, and especially with respect to the state explosion. Next one, please. Troubleshooting, the major challenge that we see is related to automated workflows and the use of active measurements. Next slide, please. And when it comes to performance metrics, the interesting challenge is that the DevOps movement has been developed to work very well within one company. And there are very interesting talks from the likes of Google and others about how they manage to motivate a good interaction between the developers and the operators or the service reliability teams on their side. However, in an operator environment, we always have different organizations. There will always be some vendors. There will always be some third party that develops a VNF and others that operate the infrastructure. So it's not possible to use exactly the same type of measures and the same type of mechanisms that were successful in the DevOps world. Next slide, please. The next steps. Comments and feedback are welcome. We would like to further refine the DevOps principles and their application in the NFVRG context, and improve the description and positioning of the languages, and identify areas where use cases should actually complement the challenges in the description. Thank you.
So now we open the mic lines for whatever comments or questions you have for Katalin.
Thank you, Katalin. So one question I have is you've talked a lot about general principles, but perhaps what are your thoughts on how DevOps is really impacted by, basically, keeping those principles in mind? Would you be focusing more on that, or what are your thoughts? Because, like service verification, all that, so what does it mean to DevOps, right? I guess that should be the focus of your draft, because we already have another draft coming up on service verification.
Right, absolutely. So from the point of view of this draft, what we want to identify is sets of challenges, not how to solve these challenges. The service verification draft, for example, it's very interesting. It's very specific to a set of use cases. In our case here, we think we are a little bit more generic.
Right. So just my thought is perhaps if you can add a little more detail into the DevOps aspect, that'll be great to take this forward.
So, sorry, Steve Wright, AT&T. Thanks for putting this together. A couple of comments or questions. You defined a couple of roles on the first slide, and I'm wondering whether you see additional roles being defined as this work continues. And the second piece is, as you started to allude in the comments about applying DevOps in operators, there may be complexities that you don't see when it's contained within a particular administrative organization. So do you see other issues with identifying trust boundaries and so forth between the different roles? Is that part of your framework here, or am I too early to...
Right. Thank you. I think that these are very interesting questions, and with respect to the three roles that we identified, I think they are preliminary. I think we are welcome. We would welcome comments and suggestions for additional roles there, and the same goes with the trust boundaries. I don't think that at this point in time we really consider trust boundaries in the context of this draft. But if this is something that becomes really important, then we can see how to proceed.
As a suggestion there, I think you might want to think about a system integration role and the notion of composing bigger VNFs from smaller VNFs and how that plays in here.
Yep, thank you.
Oh, sure. Thank you, Katalin. So, great.
I wanted to ask something, but we can talk later on.
Yes, thank you.
So we have Sarah here. Thank you. You were
missing.
You missed our appreciation to your. So that's why I wanted to make everybody know that you're here. Sorry about that. Okay, now next presentation is from Rankin, so I will take control of the. Yes, here you go.
Thank
No,
you.
no, stay in the rectangle.
Pin me.
No, not in the corner, in the rectangle. There, yes.
So I presented this draft last time. So we have a good list of current co-authors, and also given the interest in the community, we see new co-authors from VMware and Orange. Next slide, please. So just to recap what is present in IETF 91. So we looked at NFV-IaaS, what is the definition and challenges. Then we also looked at the architectural framework. Then we also looked at system analysis and OpenStack framework for an exemplary NFV policy. Essentially, this is around energy efficiency, but the metric is specified as overall utilization, CPU utilization in this case. Next slide, please. So the new additions are essentially, we also have another architectural framework on policy, basically much more elaborate, not just about NFV-IaaS. That's coming up soon. That'll be presented sometime later. And we also added another policy, which is again an exemplary policy. This is around HA, right? So basically, both the policies will be considered while doing the optimized placement. So it's not just one policy in action, how these policies interact, and we decide the placement based on both these policies. And this is essentially saying, no two VMs of the same instance, the same BNF can coexist on the same physical server, essentially HA policy. And this is expressed in data log policy language for those who are familiar with this. And what I want to highlight here is that this is a work we're really doing in open source, in OpenStack Congress. And we're going to show a proof of concept in the upcoming OpenStack Summit, and in fact, accepted submission also. So you're welcome to see the demo in OpenStack Summit. So it's happening in real. And next slide. Next steps. So basically, our whole idea is to make sure that this is something which is practical and implemented in open source. That's the whole goal. And we would like to progress the draft. So by kind of considering, do we need a separate OpenStack module for placement and scheduling, right? Rather than clubbing it with just the policy engine. And also looking at the policy engine or the the placement schedule module, how it interacts with the measurement collector, the APIs you need. So in this case, the measurement collector in the OpenStack is ciliometer, right? What are the enhancements we need, or what best we can do with the current ones? That's the areas we want to progress. And we would also like to, kind of proceed into adoption of this as a working group draft.
No. This is a research group draft.
Sorry.
We don't work here, right?
Sorry, I think that's the wrong.
We research.
It's the RG draft. I think my bad. Research group draft. So essentially, we'll also see the policy draft presentation soon. So kind of what we see is a synergy there. We'll see one is around a broad policy architectural framework, and this is around actually driving a specific proof of concept implementation and take this forward. Yeah. Open for any questions.
So this is Raj Jain from Washington University. My question is about placement. Did you consider network as a bottleneck at all in the placement, or just the server utilization?
In this current version, not, but we're certainly considering in the future versions. Absolutely, yeah. So in fact, essentially the reason for choosing the Congress policy engine is making sure that it can look at multiple subsystems, not restrict itself to just compute or storage. Basically, it can consider network too.
Aaron Gumber-Jacobson from the University of Wisconsin. I'm curious if you've taken into account traffic demand and things like that as part of your scheduling here, because it seems like while you can place an NF the ultimate resources it consumes depends on how much traffic you send to it and how it's configured.
That's exactly, I think Raj kind of asked a high-level question, if you recall. So extending on that, yes, certainly, basically all metrics on a network, which would just start off with simple utilization, link utilization, and also perhaps flow awareness, which could be, knowing about large flows or other types of flows. That's something we're trying to add, certainly, yes.
So, yeah, no, exactly. So the point is that if there is no objection, I don't think that we need to go for hams or hams rising. So let's go in a different direction that I guess would be faster. If there is any objection to, or you see that that there is no clear, or you see that this is still the document should not be in a clear. It's not in a clear situation just to go and to adopt it as a research group document. I would like to see, just raise your hands if somebody has some doubts about adopting this document as a research group document. And you will be afterward asked to come to the mic and explain and discuss why. For sure. I warn you. So Michael has some. No? Yes.
Yeah, my name is Michael Scharf. I wonder a little bit if the document is already in a stage, because it's a pretty short document with very few examples that are very specific to one cloud platform only and very specific to selected projects in that platform. And wouldn't it make sense to make this a little bit more generic, look at other policies? Policies is a huge space, and it's very dynamic space, and the draft right now takes only a very focused look at this.
No, that's definitely a valid question. So just to explain the process of adoption, the adoption shows general interest in the community and proceeding into kind of an RFC, but doesn't mean that we would stop contributing to it, just to clarify. Like the cases like networking, all those aspects will certainly be brought into this draft. That's our goal. That's basically expand on the cases and how we want to proceed. In this case, the reason we want to adopt is we want to basically proceed with the policy work, right? Also tied to the proof of concepts you're doing and just move ahead.
Yes, just to be clear, I've read the document, I find this interesting, but I find this as a very, very early stage, and so I think there's a huge potential for improvement in that area, and it also has to be clarified how this actually relates, for example, to OpenStack, because I'm not sure whether an OpenStack specific solution is of interest only, so there are other things you might want to look at. But that's just my preference. I've read the document, it's a good document.
Sure.
I want to be clear on this, but I think there's much more in that area to be done.
Fair comments, yeah, totally. Thank you.
And Ramki, I would support the previous speaker too, in the sense that I think this is a good beginning, but it has to be a little bit more mature before we adopt it as a working group a research group document. There are many restrictions from both, like you pointed out, OpenStack, and I pointed out networking. So let's work on it a few more times, and maybe then we can discuss this.
Sure. Thank you.
I think there are, I would say, valid objections. Let's wait till Prague, okay? No, let's just, we don't have any hurry.
No, of course.
Okay. No, it's valid.
Yeah, valid comments, yeah.
Okay. So let's move on. Good. So next one is, let me check in my schedule. Next one is Robert Sabo, that is going to be our star today because he's going to be in three different presentations because Su Chiang, yes. Sorry? Oh, yes. No, come here and open it. I don't understand your dull thing. And Su Xiang should be presenting here, but he is a he, right?
Yes, yeah.
He has not come, and Robert is acting on behalf of it. Inside the rectangle.
Inside the rectangle.
Thank you.
Thank you. So unfortunately, so couldn't make it, but I'm also co-author of the draft. So this is the...
1 second, please.
Yeah.
No, it's in order. It's
Yes.
in order. It's
Yes.
No, this one.
Can you hear me now?
That one.
Okay,
Yeah.
I guess it's better now.
Because he has not come. Open
Sabo.
SZABO.
Yeah.
You abandoned the rectangle.
Yes, for a minute. So actually, the draft was already
No, it's not
presented
showing.
in
It's not showing, Frankie.
Honolulu.
Whatever you did is not showing.
Yeah, it's not showing. But we did a rewrite of the draft. So I would like to revisit basically the statements there. We added a couple of figures. We added a couple of figures to the draft. So hopefully it clarifies the main message. And if I have a screen.
Yeah, we're on it. No, now? Oh. Wow. Now, yes.
Okay. Please go to the next slide then. There are some parts missing. So basically the motivation behind the draft is that network function virtualization allows the scaling of virtual network functions. And this is an important property. And we foresee that the network function virtualization infrastructure will be distributed. So it will consist of several network function virtualization infrastructure point of presence.
Sorry.
Okay, it's coming. Yes, and regarding the VNFs, it is relatively easy to scale up and down. However, we need to restart basically the VNFs in an execution environment to do so. So that's not dynamic enough, but certainly we can do this. However, if we do a design in a way that VNFs are constructed of basically smaller components, which can be just started on demand to cope with the extra load, then we will have a VNF scale out and scale in kind of features. But this basically requires a different design, which in which way we will basically create small virtual machines, and then we can start it on demand as they are needed. But if we go for this, then we basically create a group of VNF components which will constitute a VNF function. If you go to the next slide, please. Yes. And further, we have the assumption that VNFs are not just placed there, but they are part of some service. So they are part of a VNF forwarding graph, which means that they are in a sequence, a kind of service chain, or a VNF forwarding graph. And they are part of an end-to-end service, so certain service guarantees are attached to this. And as I mentioned already, there's a potential need for multiple network function virtualization infrastructure POPs, also because of the high ability and also for the distributed nature of the physical infrastructure. And if you can go to the next slide, please. So the problem is, or the figure leading to the problem statement is that we have, in this example, 2 data centers, and then we have VNFs, which constitutes different VNF instances residing in the different data centers. And if we create a VNF forwarding graph which goes through a couple of VNF instances, then we create an end-to-end service with certain service guarantees. However, for example, for a scale-out, we have to instantiate, for example, due to the load, a new instance of VNFB into the service graph. And then if we go to the next slide, this might go through the way that the new instance can only be instantiated at a distant data center resource. So this will create a problem in a way that we have to go out to data center 2 and come back. And if the networking resources is not unlimited, and we would like to still guarantee the same service specification or meet the service specification, then the ping-pong traffic might create a problem. So if we go to the next slide, what we would like to do here is that if we do a scale out for VNFB, we cannot just take VNFB into the consideration, but we have to consider the whole service graph. So whenever we are creating a scale out or scale in functionality, it is not just subject to the actual resources, the storage and the compute resources, but rather we have to take into account the networking part and maybe more specifically the forwarding graph or the service chain that the VNF is attached to. So if you go to the last slide, so basically our problem statement is that when scaling a VNF, it is not scaled in relation to the compute and storage point of presence resources, but it needs to be grouped together with the other VNFs that they are constituting the service. And these group of VNFs are subject for the auto-scaling. And this means that, for example, a VNF manager cannot really do the scale-out functionality because some other components which can take into account the whole forwarding graph should be considered in this section. So basically this leads to the observation that network and cloud resources needs user consideration, and the networking part means the interconnections of the VNFs. And we have another draft on this as well. So this concludes my talk here.
Okay, thank you. Any questions or comments?
I think in your last bullet you are separating you are not thinking the network as
no, just state your name.
Sorry, okay, Mehmet Oy with Comcast. So in your last bullet, you are basically considering network as a fixed entity or non-cloud entity. Actually, it could be a cloud entity as well, so I don't know how you want to make that statement. But
yes, that's a very good point. I will have later on a talk on this part of the problem when the network within a cloud is really a network resource which should also taken into account into the consideration. So that's really part of the problem, but in this very case we considered the wide area network as a standalone resource in this case. But that's also within the problem space.
Alex Gorbanov, Nokia. My question is about what are going to standardize, because the scaling of VM might strongly depends on vendor, and vendor decides how it's going to scale the VMs and how it's going to make the change from them, and that would depends on vendor how it's going to be it. So I'm not sure that it's possible to standardize this.
That's a very interesting question. According to my understanding, the VNF scaling should be handled by a VNF agnostic, at least some type specific VNF manager in the NFV architecture. So it's somehow independent of the service function itself, but rather considering just certain properties or types of the network function.
It's not fully correct. It might depend on the vendor, how vendor decides to put the change of the VMs.
That's not that clear, I'd say.
But at least there are definitely cases when it depends on.
No, for sure. Well,
yeah,
if you allow me, no.
Please go on.
No, for sure there will be cases in which a vendor can retain. I mean, the developer of the network function can be a vendor or can be an open source network function. You never can want to retain some control of how you scale in and scale out. But on the other hand, a VNF per se is only a piece in the machinery. If the network service provider that is using it or willing to use it makes a requirement to say, well, I want to orchestrate together with other functions how I perform scaling, well, that's something that is part of the freedom of the provider and the consumer, and it's maybe that makes sense that in some cases VNFs has to be fully controlled by the provider for whatever the reason, but in some cases.
Yeah, I mean that's good to consider that there should be some freedom for the vendor also.
Yes, actually I agree with the statement, and also, but still in this case, even if a VNF is developed by one vendor and there's another VNF developed by another vendor and they are in a chain, then these two VNFs together should be considered, because you cannot just consider a single VNF and scaling out because of these dependencies.
Okay, we can discuss this offline.
Okay, thank you.
Ahmed Mohanna, Huawei. I think Alex is bringing a very interesting point. This is just tell me if I wanted to forget about virtualization altogether, and I wanted to look at the current state of how operators handle their network. Somebody wants to assume that those MME or serving gateways or PDN gateway or SPG DW randomly just pop up in data centers. That doesn't work that way. I mean, my understanding of VNF architecture altogether is for wireless operators. We're not doing for Joe service provider. So if it's for wireless operator, these have certain control, and actually there is a very delicate process of these instantiation of VNFs. So it's I really share the same comment of Alex. What we have here to standardize.
First, we are not standardizing anything. This is not an IETF group.
I understand, but I mean, it's all. Yeah, I understand. It's an interesting topic to raise that we have this, but even just other than highlighting the problem and telling the operator, hey, you have been doing this for non-virtualized network. Please don't forget to do it for virtualized. That's all what we can say.
I would say this has maybe even architectural implications. Like, I mean, if you consider that the different network function virtualization POPs are managed by different VIMs, as this is in the architecture, then a single lifecycle VNFM manager must interact with multiple VIMs. So the resource management part is not as easy as it if it goes beyond a single POP. So I think what we are arguing here is, of course, this is just a challenge or a problem statement, that for these kind of use cases, we have to consider how to possibly solve this, and then where to standardize this. This is not part of the work here. Please.
Well, yeah, I understand, but I think it's more interested of highlighting the problem of a VNF that is span over different virtual machine of VNF components, because that's a challenge by itself. And the literature just highlight very clearly that replacing a single one physical box function by several virtual machines for virtual machine components for virtual machine VNF component is probably a performance challenge. And maybe it will be a performance hit that the operator needs to consider, and the developer or researcher need to.
Thank you.
So just one thought. Essentially, I think it's a good problem statement, but perhaps if we can look at the analytics draft, it's already there, also tie it together, so kind of see how we can solve those problems. From a research perspective, that would be, I think, great to take it forward. Just my thought.
Yeah, thanks.
So, Robert, do you plan to go further in this beyond the problem statement phase, I hope?
We have to see that.
Yeah.
Okay.
Okay, thanks. That's why, yeah.
Yes.
Okay.
Great.
Oh, thank you. So, next is Myung-Ki. Don't move it that much. So. No, indeed. Stay in the rectangle, please.
Oh, okay.
Otherwise, the rest of the world is not seeing you properly.
Thank you. My name is Young-Ki Shin. This is a brief update and review of this draft verification of NFV services problem statement and challenges. Next, please. Okay. Since IETF 91. Basically, the title has been slightly changed to problem statement challenges. The authors wanted to focus on the research problem and architecture. The rather than architecture issues, because we are the research group. And co-author Taewon Kim from Network Operator has been also newly added. He is now reviewing this draft intensively from network operator perspective. And finally, verification framework, which describe how to add verification services in the current NFV framework, is newly revised and discussed based on the current NFV phased works, especially terminology and current framework. Okay, next please. Okay, so as you know, the motivation is incomplete or inconsistent configuration of NFV or VNF, and there's forwarding graph occur service training may lead to many the verification issues, for example, the reliability or security issues. So network operator need to check consistency and safety of network service configuration on virtual resources as well as physical resources. So this draft mainly discusses the research problem related to the verification topic, which are network and service property to be checked, including the dependency of the NFV network service component, loop-free in VNF forwarding graph, policy and state consistency in NFV component, and load balancing optimization, and performance and security aspect. Next, please. This is the brief comparison between NFV and SDN verification property. This is simple and a lot of investigation between them. Basically, the property of the SDN are mostly related to the network level invariant. For example, no packet loss, loop-free in routing and switching, flow table rule consistency between multiple applications. So we also think it is much easier to detect this the SDN, the property. However, VNF context is related to the service level is much more much harder to detect some verification issues. So we need to investigate this aspect more carefully, I think. Next, please. So we also try to summarize the minimal requirement for the verification framework. We have just four. The first requirement, it should be able to check global and local property and invariant. We assume that the root freeness and the resource isolation between VNF can be regarded as global. The policies that are related only to the specific network controller devices are the local. The second requirement, it should be able to access the entire resource on the database in NFV as well as network state. For example, the SDN controls whenever verification tasks are started. The third one, it should be independent from specific solution and the framework and API. The last one, it should process standard protocols such as NetConf, YANG, and OpenFlow, ITRS, and etc. Next, please. So one of the big issue is how to add this verification service into the current NFV framework. Of course, it is very dependent on implementation. However, we think there are three possible approaches to achieve them. The first option is to add a verification manager in the manual operation. The next one is to build the service verification service as one of the OSS services. The last option is to develop this verification service as one of the VNF. Okay, the next slide. So this is, as you know, the current Edge NFV framework. So our first option is to add simply next. Just click. Okay, add verification manager, and we can add some standardized interface between the manager and some services. Just click and click. Okay. And next option, okay, next slide, please. Okay, next option is just simply add the services in the OSS. So next, please, and next. Okay, the last option. Okay, just implement the verification service in one of the VNF services. I think there are too many options. However, we also think about how to implement this verification service to be aligned with the current HGNFV framework. Okay, next slide. And we also think there are a couple of the challenging issues from the academia side. For example, finding an infinite roof and real-time verification and scalability in terms of verification aspect. And the language and the semantics modeling is also very important. So we need to figure out and investigate more. Next, please. Okay, so the next step is to correct more requirements from the network operator, and we need to collaborate with HGNFV, especially TSD working group. And we are planning to investigate to be involved in open source project. As far as I know, there isn't any verification project in OPNFV or the Open Daylight. So we need basically actually has some implementation related to verification. So we wanted to contribute to the both open source project as well. And we also, I think verification is very important topic in NFVRG. So we believe this draft is ready to be the base document for verification topics. So we would like to request to adopt as RG document as well. Okay, that's it.
Thank you. Comments, questions?
Stephen Wright, AT&T. If I go back to your list of requirements for verification here, this seems to be targeted mainly at the topology of the service graph, but I'm concerned that there would be other requirements that would need to be validated as well. So things like the pinning of a particular VNF to a particular machine, or the affinity and anti-affinity rules associated with that kind of thing. So it's not just loop freeness that's important here.
Yeah. Okay. So this is our first initial thought on the minimum requirement, how to develop the verification service. So as you mentioned, we will focus on the property, or for example, loop freeness, so we can investigate the kind of how to relate the property and work. So yeah, we will do that. Okay.
And so this is trying to, as I understand it, you're trying to verify something that's already been deployed, but verification could apply at different times in the life cycle, right? Yeah. So do you discuss the consequences of doing this at different points in the life cycle or not?
Not yet, but probably we can do the different aspect, including as what you mentioned. So yeah.
Okay. Thank you. Okay.
No, don't wait.
Okay. So
say Kathleen, name and affiliation.
Kathleen Meirosho Eriksson. I have an observation with respect to your three architectural possibilities that you detailed here, and my observation is that there are invariants that are decided in the virtual infrastructure manager. So you are not going to be able to verify those invariants if you place the verification at the orchestration layer. So I think that the verification services or functionality will need to be a little bit more diffused in the various components of the architecture if you want to verify everything.
Yeah, right. But at this moment, I'm not saying architectural issues, just how, when I consider how to add verification service, which is aligned with the current Edge NFV the framework, there are too many options how to develop. Just is our initial thought on that. So I think I will consider what you concern here. Yeah.
As a general reflection, I think that depends very much of the requirements you want to verify.
Yeah.
It's an impression.
With Comcast. Actually, I'm glad that Stephen is in this room. So, as much as I know, in the NFV architecture, they have defined various interfaces, like SWA1, up to 5.
Yeah.
I think the first thing to start with the verifying those interfaces.
Right.
And then certainly you have lists. These are good lists. But I really think we should start with them first, and performance, things like that, and then see how far we can go.
Right.
So, no.
Ahmed Mohanna. So my understanding of verification tools or verification servers, usually when you verify a functionality of an entity or a function, you have that verification server emulate that function itself. So if you put it, I agree with the gentleman who just made that the architecture that you are proposing probably is not the best way or the best architecture that we should be considered. Because, I mean, if you wanted to, for example, to verify one of the virtual machine or you wanted to verify isolation in the virtual in the network, then you wanted to make sure that that virtualization server can be a virtual machine. By taking it out of that as attached to the MANO or the OSS, you completely already isolated it from the functionality itself that that's supposed to do.
Okay. Yeah. So we are the research group. So if we have the standardized item like that, we have to go to the SG, the NFV group.
Well, I think we need to clarify this. And we are a research group, okay, but this research group needs to consider some kind of architecture that makes sense for the problem statement that we have. It's still a research group. We have to start. You are also asking for adopting this as a document. So, I mean, it goes hand in hand.
Okay.
Sure. I think one point I'd like to add to your question is that I think there are two categories, right? One is the point you brought up is around offline verification, I guess, correct? It's not kind of in line, which I think Ming-Shi is proposing, right? In reality, it will be a combination of both. It's not like one is going to be a solve-all, correct? That's my thought process there, at least. So because if you go do something offline, it's not equivalent to a production system, right? Where, things are really working, correct? That's the point to be noted.
And I think the elasticity draft and this also was somewhat related. Elasticity was going in terms of capacity, right, and you are going in terms of connectivity, basically in loops. I think if you are really going to verify, when you put a new function in, by the way, I'm Raj Jain again, I'm from Washington University. If you are going to put a new function, you want to test it out in some sense that this is valid function. And I would go back to thinking about FCAPs. I mean, when we are talking about testing our performance, we talk about FCAPs. And I forget what FCAPs stands for, but capacity and performance and things like that, right? So I would like to also verify that it will meet the performance that I want. It will not have the loops, of course, but it will meet the performance, and that's when it brings up my elasticity draft in my mind. And security, for example. I want to make sure that none of the data centers which are insecure are in my this thing. So you want to really think a little bit more about this before we say, yeah, this is, so yeah, verification is an important problem, but I don't know whether we have gotten enough to say that this is a good draft to make a...
Okay, yeah.
Sure. And then in your draft where you said that you work with the NFV test function, it is just, okay, yeah.
Yeah.
That would be a good step. Once you have done that, then we'll become a little bit more mature.
Okay.
I think that collaborating with the test working group makes sense, but the test working groups must focus on, let's say, more short-term goals. It's something that probably will be a little bit, but anyway, thinking about this and thinking that mostly first comment that Stephen was, no.
Yeah, please.
Please go and then I have the opportunity to close.
Just thinking a little further, as I think about this, this seems to be targeted at a sort of one-time verification on first deployment. Is that the problem you're trying to solve, or are you trying to deal with the ongoing validation, months, weeks, days later in the life cycle? Because I mean, are you assuming that the environment is static, or that things like chaos monkeys out there are blowing things away, or what's?
I think there are too many aspects. So in this draft, the authors wanted to provide what is the problem when the network operator considers the verification when they configure the VNF, for example. But if they consider to develop this verification service, there are too many options from the standardized point of view, or as you the chair said, offline, online, and how to add seamlessly add this service into the SG NFV on the framework. But we didn't investigate all of the aspects, not yet. So we can just provide, okay, this is the problem domain, and we try to categorize the network and services on the property to be checked. Then if everybody agree on that, we can move forward how to solve this problem from the standardization point of view, or on the research point of view and implementation point of view. That was our plan on the draft. So then we can move forward step by step.
And that's fine. It's just depending on the way you define the problem, there may be other solutions here, and that's what I was trying to get at.
Yeah. So basically, S3 has the solution based on the formal specification and the formal language, but it is independent of the current SG NFV on the framework. For example, the offline verification. But this functionality is very, very limited. So if the network operator wants to add their specific requirement, for example, the functionality, we need the specific semantics language. So there are too many options to cover the kind of the verification domain, but we didn't develop yet. But from the research point of view, we can just provide what kind of aspects should be tested or should be reviewed before the VNF configured. That was the first intent in this draft. Yeah.
That's precisely what I was thinking, is that probably in order to narrow down what is the goal of the draft and focusing it and facilitating a future adoption, would be precisely that instead of talking about service verification, because mainly we're talking about here about the forwarding graph verification, right? So if you focus on that and you, reshape the draft a little bit and say, well, we are talking about forwarding graph verification. We are going to work on this. We are going to address this. That is a really relevant issue, and it's something that is unique to NFV, because other verifying, for example, the virtual machine, or verifying the SDN topology, or verifying there are other the security and verification aspects that can be addressed or have been already addressed by other parties. If you're talking about verifying the service graph or the forwarding graph, sorry, and you focus on that, I think that would help in finding a clear place for this as an activity inside the RTG, the NFRG.
Okay. I also wanted to add, if you could think about what can be done proactively versus reactively, that will also, I think, kind of add further value.
Okay, so let's move on. Thank you. And our next presenter, yes. So, well, we have another problem with the screen as usual. So, no, well, if you 7G, you pronounce it 7G. So the G, you forget about the G. 7G. Okay. So if you feel like start speaking before, where's Ranky? No?
Yeah.
Yes. In any moment, it should be shown in the on the screen. Okay.
So next slide, please. So this draft is about resource management for dynamic service chain adaptation. So it provides several use cases, including the problem statement for these challenges for management of resources. But it is its main focus is on the service chain creation or adaptation. Next slide, please. So in the previous item meeting, we have provided some problems regarding the NFV resource management for optimizing the network forwarding path. So as shown in the figure, this is one of the use cases stated at the draft. So here we have a network forwarding path with VNF A and VNF B, and if we have failed VNF instance, then the whole network forwarding path will be failed. So in that case, we can detect the failure of VNF instance, and we can replace it with a new VNF instance available in the network. So this is our main idea regarding the NF resource management. So here we are focusing on creating or updating the network forwarding path by considering the state or constraint of NFV resources. So here we have NFV instances and virtual links among the VNF instances. So we call it NFV resources in our draft. And focusing on these two types of resources, we'd like to monitor or select based on the monitoring results, and we can replace those instances or virtual links from the original network forwarding path to have optimized one. So in our draft, we provided this main idea with the problems, including use cases such as failover of the network, the VNF instances, and traffic optimization or localization regarding the network forwarding path, or we can have a load balancing cases with the balancing the load between the VNF instances used in the network forwarding path. And we could consider another use case such as energy efficiency. And lastly, we think that our idea could be applied to SFC without big changes, because we are focusing on the network forwarding path only. So we have provided a simple idea about the applicability to SFC working group in terms of control plane architecture. Next slide, please. So in our updated draft, we defined some problems. So here, the resource scheduling is needed because VNF instances of virtual links are shared by multiple network forwarding pathways for different network services. And the NFV resources has very dynamic states or constraints. So we have to consider those kind of states or constraints to construct or update the network forwarding path. And second thing is we have a big problem, the big issue regarding the resource management. So we can have NFV update versus frame scaling. Initially, our draft is focusing on the NFV only. That means our main idea is to construct NFP or update the NFP by selecting or replacing the existing VNF instances. So we are not talking about the scaling of the virtual machines for VNF instances at this moment. So because until now we could not find any additional or different approaches regarding the frame scaling about the network forwarding pathways. But we are open to this issue. So next slide, please. Okay. So we have added two additional use cases. First one is path optimization. We can construct the network forwarding pathways by considering the constraint of the NFV resources for better end-to-end QoS. And endpoint mobility. If we have the changes of network attachment point of the endpoint, and we can relocate of the VNF instances for NFV update. Next slide, please. And we have applied our approach to the one of the SFC draft named the control plane architecture. So in section 5.4, we have added the path adjustment with the control plane architecture of SFC because we are focusing on the network forwarding path, and in the same manner we can elaborate our path adjustment approach to the SFC. Next slide, please. So we have several issues regarding our further development of the draft. So the resource allocation or scheduling is an MPL problem. So at the first stage, we'd like to try to address the problem with some heuristic approaches in our draft, but we expect more detailed algorithms by other contributors. And we have issues regarding seamless virtual machine migration at replacing the VNF instances. Actually, we have many kind of approaches regarding this one. For example, we had some presentation in the IETF open meeting on Tuesday, so it could be one good candidate. And regarding the document scope, we are initially target on the architectural contribution, use cases, algorithms, or applicability to the SFC control plane. And we are focusing on NFV update or construction, but we are further expecting some forwarding graph update or frame scaling. Next slide, please. So here we are conducting some simulation and prototyping with the open source project, and we can elaborate more text based on those simulations or prototyping in our draft. And we expect more detailed algorithms with some contributors, and we are looking forward to having our draft adopted as the RG draft with more mature text. Thank you.
Thank you. Don't hold the mic. We are running out of time, so well, I think that one question and whatever else you have will be taken out to the line to the list. So if nobody has anything to comment, I see there is a very direct connection with the previous elasticity draft, and I would encourage you to try to find a way of collaborating, because it will be interesting. That's
Yeah, I think good idea.
okay. Since nobody of you have stepped up to complain about this being immature or not very well aligned, I think that probably we will start some poll inside the list, precisely asking for adoption of this one, which seems to be much more focused on oriented to a particular solving a clear problem. Well, our next presenter is again Robert. So now we have the usual problems of. You please start. Go on. Don't be shy.
Okay, so I'm back again. So this is again a revision to a problem statement and challenges draft that we presented it at Honolulu. It's about unifying carrier and cloud network resources. And there was a discussion about the architecture assumption. And basically in this draft we argue for a need of joint virtualization abstraction and programmatic interface, which can consider both compute and networking resources. So the idea behind this is that in today's MANO architecture, there's virtualized infrastructure manager for each POPs. And what we see is that if we consider technological domains or administrative domains, we cannot really go with this separated resource managers, but rather we encounter use cases and scenarios where we have to take into account compute and networking resources jointly. So whenever we split these resources, we argued through this draft with a couple of scenarios looking into the cloud resources in different Zoom levels. We argued that we end up in all of the cases with a network problem as well. So we cannot go for a compute problem only, because if we zoom into the compute problem, then we will encounter with a network problem again. So in different Zoom levels, we always see that there's a network in behind. If you can go to the next slide, please. So that provided us the motivation behind our work. We analyzed the different compute domains, and then we argued that there's a need for joint abstraction for software and networking part. And if we have this joint abstraction, then certainly we will have a joint programmatic interface for this. This can be considered as a VNF forwarding graph on its own in the ETSI MANO framework. But what we argue for is that this can appear at multiple levels depending how we view the resources. And I will have another presentation which directly tries to illustrate this in the context of a VNF forwarding graph.
In 10 minutes, yes.
Yes, in 10 minutes.
If you are fast enough.
Yes. Okay. Go to the next slide, please. So what's new in this draft? I put the original figures to the end of this presentation, so if you are interested and you don't have the draft in hand, I will not go through of those figures now. But what's new in this draft is we splitted the problem statement and the challenges. And this was deliberate, that we would like to elaborate with this draft to collect the associated challenges and evolve this to a potential research group adopted draft. So at the first version, we discussed the orchestration challenges because that provided the motivation for our work. We extended this with resource description, dependencies or decomposition, this elastic VNF that I already presented, and some measurement and analytics, which Katalin has presented as the first presentation. So if you go to the next slide. So this was basically the original problem statement from us, that we have different technology domains. For example, there's a wide area network in between, and there are two data center POPs at the edges. And what we would like to achieve is to do a VNF forwarding graph orchestration above these resources. And then in the original draft or the first version, we zoomed into the different technology domains and encountered a network problem as well. But the way it is done today is if we go to a data center POP, then it is assumed that, for example, an OpenStack controller is in action there. But we cannot really communicate networking requirements for an OpenStack controller, and we might end up with wrong or not optimal placement of the VMs within the data center network, or even we cannot really communicate networking constraint for that part. So if you go to the next part, next slide, sorry, then from resource description point of view, it's really hard to come up with arbitrary resource description, because at the end of the day we would like to consider when doing the orchestration, for example, CPU resources, but also we would like to take into account whether there are hardware acceleration at certain places in the network. And also for the networking point of view, if we will have hardware acceleration for complex functions that we can place as OpenFlow 2.0 or something like that within the network, it makes a difference when deciding where to take a forwarding path. And then sometimes we have to consider quality of service specification, but who knows whether the QoS specification for a certain service, what does it mean? Can we have a proper abstraction for that? So it might be that we need a control component within the forwarding graph, within the deployed service, who can tell about the quality of service parameters that the service is experiencing it. And then we might need to take this into account when orchestrating or reorchestrating or optimizing the forwarding graph or the VNF forwarding graph placement. So the resource description problem at a proper abstraction is absolutely not trivial in our understanding, and this should be considered. Next slide, please. Then the dependencies or the decomposition. What we see today is that at the application layer there are languages which can describe these kind of dependencies. So for example, we can take the Tosca. If we go into a data center, we can find similar dependency descriptions. But for the orchestration, we have to select the placement of the VMs or the VNFs by the means of the different hardware capabilities and the resources. So is there a proper abstraction which we can take into account when deploying from the VNF graphs or from the high-level application definitions to the low-level cloud-specific dependencies or decomposition? Can we take this into account? For example, if we have certain hardware accelerations at a certain site, then we can go for that. But we have to understand this at the resource orchestration level. So, okay. Yeah. So this is one other issue which we have to consider. If you go to the next one. Then this elastic VNF. I already talked about this, so I will not go into this detail. I will spare some time. Go to the next slide.
It's just for you to have time for the other one. I mean, it's
and also for the
up
questions.
To you.
Yes.
Up to you.
Thank you. Yes. And for the measurements and analytics, we can take a static system into consideration, and I think that's very much what comes from ONF SDN architecture. We create static virtualization, but then on the other hand, we have to run and operate these services. So we have to reevaluate and reoptimize this, as we have heard from the previous presentation. So we have to take into account how we can do this for a compute domain and how we can do network benchmarking, benchmarking for the network domain. And it might be that for even a whole service graph or a forwarding graph, we would like to evaluate whether if we place this at this network function virtualization infrastructure POP or another, what kind of service guarantees we can receive. So this is, again, one of the challenges associated to this space. If you go to the next one. So in summary, the way we updated the slides or the draft is that we split the problem statement and the challenges, and we try to evolve with different ideas in the challenges section, and these are the 6 or 5 areas that we covered so far. And we are looking for feedbacks here.
Okay. Question, comments? Well, we start.
And I tell you, Comcast, I think some of the verbiages are very confusing. You started with, say, software and then network. The network can have software too. And then you come down here, you say computing and network. Network can have computing too. What are you trying to really do? Can you describe them properly?
Yes. Okay, sorry for the confusion. So the way we see is that today the cloud is assumed to be a compute or software resource, and then inherently it has a network part. But when you request, for example, from the OpenStack controller, you request virtual machines, but not really the networking part. Networking part is given. for example, as a layer 3 address, which is accessible. What we see here, what we try to argue here is that it is not enough if you consider a compute resource or software resource, a cloud domain, but you have to add the networking part, because you would like to define, or at least we would like to define, how the networking behavior within that cloud domain should look like. And this is our argument to combine the cloud abstraction, cloud resource description, and the network resource description into one virtualization, one abstraction, and to exercise a joint control over this.
Al, please.
Al Morton, speaking as co-chair of the IETF Benchmarking Methodology Working Group. Your slide 8 mentions benchmarking twice. No need to do research on that. Please come to join us.
Yes.
That's a great point. I think that's a great point. Yeah, thanks.
Great. No, but this is precisely what we intend to do in a research group, precisely to produce results and go to the working groups.
Yeah.
That's the second one. First, the chirurgic, if I pronounce it well, was mentioned in this connection with SFC. I made it. Okay, thank you. So, well, now the second one, you have 15 minutes for this one. This is the other one.
Okay,
yeah,
so you
changed. Recursive or stuff.
Yes. Okay. So I stay here. I was
Yeah.
thinking about going back for a minute, but then.
Exactly.
Okay. So at this draft, we would like to go into detail and argue for this kind of recursive programming. So in the previous draft, we argued that we need a joint representation, abstraction for cloud domain and network domain. And then here I would like to show why this is a good case, and then whether this is enough or not. And the argument here is that we need this in a recursive nature so that we can create a multi-level architecture for resource orchestration. What I would like to do here is to look into a data center scenario where we would like to place network function chaining as an example use case. And then I would like to walk through a layer 2 and layer 3 encapsulation, some layer 2 and white box, and a recursive approach to with joint compute and network virtualization and programming as our proposal here, and then a summary. So if you go to the next slide. So this is just an example scenario. We have a data center at the bottom, and we have a wide area network on the top. And then we have a service orchestration, for example, a network function virtualization orchestrator. And we have 3 network functions which define a VNF forwarding graph. And this is to provide the service for a customer. And what we see in a HTML framework is that for the cloud virtualization, we will have a cloud controller. And if we consider this, for example, an OpenStack controller, then the OpenStack controller through the Neutron interface will talk to an OpenDaylight controller to configure the data center network. And then we will have a wide area network controller, which can again be an SDN controller, which will configure the wide area network. So this is a kind of basic setup. We have 2 VIMs because of the 2 technologies or the 2 domains. And then we would like to deploy the VNF forwarding graph into this setup. If you go to the next slide. Okay. Yes. So what you can see here is that if you would like to apply layer 2 and layer 3, for example, the VNFs deployed are bump-in-the-wire network functions. So we would like to put these as a transparent service offering here. Then we have different options. For example, the switch within the wide area network could control all the traffic chaining. This could be the service function forwarder in the SFC terminology. So we request the placement of network function 1, network function 2, and network function 3 from the cloud controller, but we can just request VNFs. So the VNFs are deployed without really considering their interconnection nature. So they are picked randomly, basically, by the OpenStack controller. There will be a compute node assignment, and the virtual machines will be started. Now, if you would like to put this into a forwarding graph as the original request, then we have to configure layer 2 and layer 3 tunneling, for example, using VXLANs, and the VXLANs to be terminated at the WAN network. This is one potential way to do this, because then the service provider or whoever controls this network, without relying on the network functions, will have full control of the forwarding path by the means of the switch or the network function, network element that is controlled in the wide area network. And we have the freedom, so if any of the network functions are moved around within the data center, for example, a new instance is to be created, then we can control it without really communicating or affecting the other network functions within the deployed data center, because the forwarding path is configured purely on the network element in the wide area network. So there are a few pros and cons besides this scenario. So if you go to the next slide, then we can do this in a way that we don't need to go out to the wide area network, but we can configure the forwarding within the network functions itself, because they must support this layer 2 and layer 3 encapsulation, so we can configure the next hop address. The problem here is that we have to rely on the network function itself, which is a virtual machine, and we have to configure certain parameters within the network function. But this can be developed by a third party. So the problem, in the first case, we were okay because we configured the network element, which could be considered as maybe as a trusted network element, but in this case we configured the VM itself, how to do the forwarding. Of course, we gain something that we are not coming out from the data center and going back each time we have to go to the next hop. Okay. If you continue to the next slide. So if you change this scenario in a way that we would like to exercise network control for the internal data center, then the way we can do this, potentially, is to expose the northbound interface to the data center network's controller to some external control entity. However, we will spoil the authoritative or administrative domain boundaries, because we have to exercise direct control of the forwarding within the data center. So what we can do, we can still request VM placements all over the data center network, but then we would like to set, for example, direct layer 2 forwarding between the deployed virtual machines. And the only way to do this is that to connect to the controller of the data center network and instruct it to establish this layer 2 forwarding. So it has a few pros and cons, but at the end of the day, the real problem is that we are just going over the administrative domain boundary by directly communicating with the cloud network controller and also with the gateway. And now if you go to the next slide, so the thing that we would like to achieve is to express within the cloud domain how the networking behavior should like and how to connect the different network functions, and as well where to place them. The placement should be done in a way to consider the forwarding in between. So what we can see here is that if we could express by the similar way as we expressed at the top the VNF forwarding graph as an input to the overarching orchestrator who decided where to place certain functions, if we can provide this kind of constraints or topology together with VM resources and network resources to the cloud domain, then the cloud domain could do the optimized placement and establish the networking as well. So what we are arguing here is that at the level of the cloud domain, we should have a similar interface as we have at the service orchestrator, because we would like to see basically the same parameters and the same constraints and the same considerations going down to the cloud domain. But this requires a kind of joint virtualization of cloud and network resources, because we had this joint virtualization of cloud and network resources at the top, because we could express not only network function requests, but also the networking parameters. If you go to the next slide. So then, this is a figure from the draft. So what we are arguing for is that for the overarching service, we express something by the means of a VNF forwarding graph. However, this boils down that within the domains, within the technology domains, we would like to see a very similar request in order to handle this properly. So if you go to the data center as a cloud resource, for example, we would like to see a VNF forwarding graph as a split from the original VNF forwarding graph. But this requires recursions in this resource orchestration or resource programming.
Questions?
Great. You made it right in time.
Yeah.
Perfect. I have a reflection to do because it's during this is in the ONF architecture framework. Precisely a colleague of yours was precisely complaining that NFV was not supporting recursion. And it's quite curious that you're claiming for recursion as a natural construct to be used here. So, I mean, I fully agree with you, so it's not that an argument, but it's curious that the perception that is outside of the people that are working currently on NFV is that we are not supporting recursion.
Are you supporting recursion?
If we need to go in that way, we should support recursion.
Yes.
That's my point.
That's a nice statement.
And I think also the same thing, right? I mean, the recursion, the value is not very obvious because, you know, as you can see, yes, we need to be hierarchical, or I can see that clearly global optimization will produce the results you're talking about. But what exactly the value recursion is delivering is not very obvious. Perhaps we can bring it through some examples, saying if something cannot be accomplished without recursion, something can be, then I think that will make the overall draft much more meaningful and powerful. That's my thought. It has to be kind of with an example, because otherwise it's not too obvious.
But that we try to do here with this.
No, not with, I mean, basically with kind of, I would say, more like a system analysis example itself. I think that would drive, you know, more meaning, at least to, you know, people who are implementing such a thing. Right? Just my thoughts.
Okay.
Any other comments, questions? Come on, they should make you jump on you.
Yeah.
Talking about, yes, please.
Thank you, thank you.
So Anup Ghanwani from Dell. The question or the comment that I wanted to make is this seems to be more like a multi-constraint optimization problem. And so you can fix one and optimize the other, fix the other one and optimize the first one. But ultimately, you know, like if you try to optimize both simultaneously, you get into this NP complete thing, and maybe what you're suggesting is somehow by doing some kind of recursion that you would actually be able to solve that complexity.
Yeah, from algorithmic point of view, you are absolutely right. What we are arguing here is that do not separate these resources. So the way we see it today is that people assume that if we go for cloud, then we request VMs, and that's all. However, if you would like to have this network function virtualization, and this is to put into a service, then we always have a networking issue. And whenever we separate this, we can separate this, but then in another channel, we should have this networking consideration attached to the VM request, because they should be considered jointly somehow. But then, from algorithmic point of view, you can go first for a network optimization and then check your compute resources, or you can make a compute selection, but still somehow considering, for example,
the bandwidth.
Yeah. To place the VMs nearby to each other, or considering the top of the rack switches or something like that topology. So how you solve this algorithmically is really difficult or might be a hard problem. But we would like to keep the constraints and the requirements together. That's our point here. And then, of course, we have to go for different algorithms.
Okay, thanks.
Thank you, I think great comment. Just why I was asking for the system analysis. So thanks. Just follow basically that will kind of, you know, kind of drive the use case much better. Yeah.
Okay, we will do.
Okay, so we close with Ranky, that will close the session as well. So question.
The favorite policy topic is back. So it's mentioning we have another draft on policy. Unfortunately, Norival cannot make it to the meeting, so I'm presenting. So what we talked about before was a specific kind of policy architectural framework for NFVIS driving to system analysis. In this case, it's much broader. Overall policy architecture framework for NFV. Next slide.
Better, that way I
So,
don't stop.
Essentially, what you're thinking is basically starting from the top, how to type business rules and then specific and different types of resource constraints across different subsystems, which include compute, storage, network, and also energy constraints.
Excuse me, I can't hear what you're saying.
Oh, thank you.
The mic doesn't go.
Sorry about that.
No, move your hand at the same time to move the head. Or
So essentially, what I'm saying is this is about starting from the top, essentially looking at business rules and then different types of constraints in different subsystems, looking at network, compute, storage, and also energy constraints. And this is not about policy theory, which has been well covered over last 15 plus years. And this is about an architectural framework for NFV, just for clarification regarding the scope. Next slide, please.
No, sorry.
So the main topics you'll cover are, the first is the policy, which is essentially intent, what the customer wants, and versus what will happen in different subsystems, including configurations, and global versus local policies, and the hierarchical policy framework, and how we are going to handle policy conflicts and resolution, and also policy subscriber publisher bus, which we'll discuss. Next.
Sorry?
Yeah, it's okay. Yeah.
No, here, right? No, the problem is that it's showing me below, but.
So essentially, as you can see in this example, what you're giving is, an intent statement. So essentially, the intent is, the customer must be given platinum treatment. So now that results in different types of configurations in different subsystems. For example, in the compute,
glasses. You need You're getting all of them.
So essentially in the compute,
please.
This could translate to using a specific type of server, right? 16-core Xeon processor-based server. Or in network, it could mean best QoS with a certain DSCP value. So essentially the idea is all this configuration is not a particular, it's all programmable. But that means the platinum treatment is the intent, which results in a programmable configuration. That is a key aspect here. Or in the case of storage, we are saying use SSD storage for platinum treatment. Next slide. So now moving on to the topic of global versus local policies. So if you recall my previous presentation, we talked about the Congress policy engine and global policies across different subsystems. And yes, that will solve a certain category of problems, but it's also equally important to realize that there are local subsystems with local policies, and in fact, that is probably the 80% case. A network subsystem will have its own local policies, and compute does so, like storage, local policies. And for example, network, that will be handled by the controller, if you're talking open source, something like OpenDLA. And it's important to make sure that all these interact with each other and then exchange information. Right? That is the key aspect here. Next slide. So, and also moving on, what you have to realize is the policy framework is essentially hierarchical, right? Where a lower subsystem, right, could essentially be part of, basically be abstracted by a higher level subsystem. Correct. That is the abstraction layers we're talking about, right? So, for example, in this specific example, where there is a region domain, right, which encompasses a DC domain, different DC domains, data center domains, and a WAN domain, whereas and this can be further abstracted to a higher level domain. The configuration happens typically in the highest level domain, and then it percolates hierarchically. So that's where it's not necessary that there is this Uber policy engine. You could always have another one, basically level in the hierarchy which abstracts that. And the levels in the hierarchy is not necessarily limited. It's more of an implementation limitation. Next slide, please. So with all this introduction, what you have to realize is in this landscape, policy conflicts and resolution is a very important topic, right? As a practical example, when a new policy is added to the subsystem, you need to do conflict checks, right? For example, in this case, the first policy which is existing is customer A must not be allowed to use a particular VNF X. And now we are adding a new policy saying, P2 saying it's allowed to use the same VNF. Then the conflict resolution is important. And why I'm bringing this up is essentially all this has to be done in scale, right? Essentially how you check the existing policies, run through them, and make sure there are no conflicts, right? And also, though this is a very simple example where it may seem so trivial, the complexity arises in how you enter policies, whether you enter them one by one or more like a batch mode. That's where the real complexities come, implementation complexities come. And also the other very important part I would like to point out is the reactive versus preemptive conflict resolution mechanisms. By preemptive is essentially, typically during configuration time, you check exhaustively, hey, are there any conflicts, right? But in many cases, especially just rolling back to the previous presentation on NFVIA is, practically speaking, if you are optimizing on overall utilization or energy efficiency, it has to be something reactive, a continuous process, because at the bottom, all these utilization is continuously changing. You cannot say that, hey, I will do some initial placement and leave things at that and move on. That is the reactive aspect which also needs to be considered. Next slide, please. So now what we also see is another important part, essentially how policy engines need to communicate, right? So this is to make sure that all the engines are synced with respect to policies and conflicts are resolved in a continuous manner. So for example, so you may say that in a local compute engine we have a local policy saying platinum treatment must be provided using server of type A. And that could be overridden by a global policy engine for further optimization, right? And this is again last topic where Robert presented, right? Global optimization and how we do things. And in this case, essentially a good way to resolve this is kind of have a subscriber-publisher model on interesting, entities which you would like to track, something which is common to both of these, and then you subscribe to these updates, and then you figure out there are any conflicts, And again, here, as what we are seeing is essentially all of this cannot be proactive because it's, it'll be exhaustive and probably be NP hard problem even. So it'll be more of a reactive mechanism where something happens and you trigger that, hey, there is a problem, we need to resolve it. But the most important aspect is there is kind of a subscriber-publisher model needed, and also the fact that in a multi-vendor environment, these policy engines will have different policy languages, and how you translate between these engines and communicate information needs to be looked at. Next slide.
You have 1 minute or two.
Oh. So I think to summarize, we went through the topics. I think what I want to highlight is though we talked about NFV, the applicability of this framework and architecture is much beyond NFV. It could be applicable to enterprises, especially branch offices, where you see NFV type constraints. Branch office can be kind of considered similar to a central office, NFV central office. And we talked about related NFV IAS draft. And also, as we move forward this draft, we would like to discuss different conflict resolution strategies and how we relate to the subscriber-publisher loss. And we'd also like to request research group adoption for this draft and move this forward. And any questions?
So there is one more. This is Raj Jain from Washington University again. So there is one more dimension in policy, particularly in the multi-tenant environment in which we are here, is that cloud provider has a policy and the cloud tenant has a policy. And there might be some conflicts in some cases. And so there has to, I don't know whether your publisher subscriber model will solve that, or I don't know the solution. I know the problem for sure. And then what will happen is, in the NFV case, there will be multiple cloud providers because, of course, it will not be just one cloud, and each of them may have a policy, which may be different from the tenant's policies. And so that dimension, I don't know, that is not yet in this draft. It looks like you have global versus local, but both of these policies, I don't know where they fall in.
That's a good question. So what we're envisaging is essentially kind of a hierarchical policy framework where we'll make sure that through a subscriber-publisher mechanism, like you brought up, we facilitate what information is exchanged and how policy conflicts can be resolved. Like global and local, we are not restricting to 2 levels in hierarchy. It can be any levels. For example, even a switch, figurative model could have abstracted. For example, the platinum treatment could go down to a switch, which could do a QoS action right there. And then there is controller, which is one more level in the hierarchy. Then you have like an orchestration system. So we're not limiting ourselves. I hope that answers your question reasonably. Or I think at this point we could take offline also because as you're, yeah. But
Steven, you are the last one. For those of you who are running away, remember that we start here at 5:40 p.m. again. Not here, yes. We are, SD Energy is not here, NFVRG is here.
Yeah.
So just Steve, just quickly, it's certainly fair game to have research considerations about the intersection between policy and NFV, but I suspect we need to be a little bit more concrete about what kinds of policies you're talking about and how they may fit in here before we can take this into an RG adoption stage. So
sure.
There's lots of different types of policies. We need a few more adjectives in there. Thanks.
Thanks, Steve. Thank you, everybody. See you at 5:40.
5:40. Well, I guess that who has the other blue sheets been there? Great. Oh, but there is another one coming, so. Hey. Well,
good session.
Two parts. Oh, it's always two parts. I'm probably